Hello friends, I welcome you all in this session. As you are aware, in previous session we were discussing about one way ANOVA, and we have seen that in one way ANOVA we have got a dependent variable and an independent variable. In independent variable we have seen there were different levels. For example, in one of the examples there were the sales of a mall, and the malls were in different geographical locations, let us say in cities, in semi-urban area and in village area, right. So, all these cities, village and semi-urban, all these are treatment levels, right, under independent variable geography, and the dependent variable was, let us say, the sales of a particular product. We have seen Tukey test wherein we compared means of different groups when the sample size was same. Let us look at the extension of Tukey HSD test. It is called Tukey-Kramer test. Now, this test is applicable when we have got unequal sample sizes. So, this is basically extension of Tukey's test. It was the extension was done by C.Y. Kramer in 50s. So, the formula for these two tests are almost same with minor differences. So, if you look at Tukey test, then this was the formula for HSD. Now, this particular value has been added to this formula. So, what we have done? So, there is nothing, no difference except that mean square error is divided in half, just see 1/2, and weighted by sum of inverses of sample sizes under root sign, right. So, this is what is the sum of inverse, right. So, mean square error is as usual, which we obtained in HSD test as well. Sample size of Rth sample, sample size for Sth sample, right, and these are different values which you will get in table, right. So, at this particular combination, right, critical value of studentized range distribution from table, right. So, let us look at an example. This is an example wherein though we have seen this example, this is an example where let us say there are 4 operators and they are making valves, and these are different valve opening diameters, or put it in simpler words, there are 4 operators and they are drilling on an aluminum plate, and let us say diameter of the hole they want to have is 6.25 plus minus 0.10 mm or centimeter, whatever it is, right. So, is there any significant difference amongst means of these 4 groups, or can we say that the mean of these groups same when these holes are, the valves are being made by 4 different operators, right. So, this is TK test. The formula for this, we have already seen all these values. So, let us look at the solution to this particular question. We will test it at 0.05 significance level. So, we will calculate sum of square, column sum of square, error sum of square, total sum of square at appropriate degrees of freedom. So, this is f value which we have calculated, right. So, this is the type of distribution, this is your rejection region. So, this is f value somewhere here, and we will have critical value from table, right. So, just keep in mind this particular values. So, in this formula if you look at carefully, you have got when you take first 2 samples. So, first sample has got sample size 5, right. So, this is 5. Second sample has got 8. So, 8. So, the value of Tk is Tk test is 0.1405, is not it. So, we know this, that there are 5 units in first sample, 8 in second, 7 in third and 4 in fourth sample, and these are different sample means. So, if you look at the f value carefully, this is somewhere here, right. In fact, this is not equal to 1 or this is not near 1. So, we will say that we are saying we will reject null hypothesis, right. We are rejecting null hypothesis. We are rejecting null hypothesis, it means that these means are different from each other. So, this is what ANOVA does, but it does not tell you which group of means are different from each other. So, that is why we are using something called Tk test, right. Okay. So, when we calculate Tk value, this is nothing but Tk, Tukey-Kramer value, right, 0.1405. Now, we have to compare this value with the differences of means. So, let us take first and second group. So, the mean difference is 0.04, this is the difference first and second. So, the difference is 0.0405. Now, compare this value with calculated Tk value. Now, this value is smaller than this. So, we will say that there is no significant difference between group 1 and group 2. There is no significant difference. So, it means they are same. So, mean of group 1 and mean of group 2 are same, right. There is no statistical difference. But what about between group 1 and 3, is not it? You need to calculate. Then what about 1 and 4, 2, 3, 2, 4 and 3, 4. So, you need to calculate all those values, right. So, the actual differences are this, right, between let us say group 1 and 2, this is the actual difference, between first and third this is the actual difference, and so on, right, third and fourth this is the actual difference, and the critical value is 0.144 for first and second group, first and third group. So, if you take first and third group over here, so first is 5 and third is 7. So, the moment you write 7 over here, this value becomes 0.1443, right. When you take first and fourth group, it means this 5 and 4, this becomes 4. So, the critical value becomes 0.1653, right. Now, you compare each pair with the actual difference, compare critical difference of each pair with the actual difference. So, if the difference is more, if actual difference is more than this, then there is a significant difference. If it is not, then there is no significant difference. So, let us look at this. This actual difference is less than critical difference. So, we will say there is no significant difference. This difference is more than critical. So, we will say there is a significant difference between first group mean and third group mean, and so on, right. So, there is a significant difference between 3 different groups, right, first and third, second and third and third and fourth, right. Otherwise, there is no significant difference between first, second, first, fourth and second and fourth. So, this is how you can solve a question like this, and this is the computer output. You can use any, when I say computer, it means you can use any software, be it SAS, be it Minitab or be it SPSS, right. So, if you look at this output, Then let's compare group first and second, right, first and second, right, or operator 1 and operator 2. So, if you look at the upper limit and lower limit, so this is the lower limit minus this and this is upper limit, right. So, if the confidence interval includes 0, there is no significant difference between those two groups, right. So, if you look at group 1 and 2, is there any 0 between upper and lower limit? Yes, there is 0. So, we will say there is no significant difference, they are same. Let us look at 1 and 3, this 0.31, 0.02. So, there is no 0 in this range. So, we will say there is a significant difference between 1 and 3, which can be seen here as well, is not it. Let us look at any other group, for example, group 2 and 4. Okay. So, of course, there is a 0 value between lower and upper limit. So, there is no significant difference between 2 and 4, just see there is no significant difference. Star means there is a significant difference at this value of alpha 0.05. Okay. So, we will solve this question using Minitab, and this is the output we would be getting. So, let us first go for data entry. So, this is the question and let us look at the software. We will go to software and we will go for data entry, right. Okay. So, this is how you can do data entry for this question. So, let us look at these values 6.33, 6.26. So, this is how you should be doing data entry for each of these groups. Keep in mind that we are solving this question using TK test because the sample sizes are not equal. So, in first group there were only 5 samples, in second group we have got 8 samples, in third group and fourth group again we will make data entry. So, 6.22 is the last value for 8th observation in second sample, 6.58, 6.54, 6.56, 6.34, 6.58. So, there are only 7 observations in third group. So, far as fourth group is concerned, the first value is 6.29, 6.23 and the last one is 6.21. So, we will go to state, we will go to ANOVA, we will go to one way ANOVA. Okay. So, this is So, we can select all these values C1 to C4, select. So, all these values will come over here. We will go to options, we will check the significance level. Let us check once again significance level for this question, and the significance level is 0.05, right, it is written over here, right. So, we will go to here, it is 0.05. So, this is a left tail test or low tail test, it is not a two. So, this lower bound, we will click OK, we will go to comparisons, we will put a Turkey, right, and test, right, click OK. Once again there is, of course, there is no need of all those graphs, we will click OK. So, this is our, we can minimize these values. So, just minimize this and this as well. So, look at this particular table values, right. Now, if you look at carefully, this p value is 0.85, which is greater than 0.05. So, there is no significant difference between first and second group. What about this 0.01 is less than alpha. So, we will say that there is a significant difference between C1 and C3. Similarly, this C2 and C3 there is a significant difference, and C3 and C4. This is what the same you are getting the same result which we were getting in Minitab. Let us look at once again. So, there is a significant difference between 1 3, 2 3 and 3 4, right. So, 1 3, 1 3, then 2 3 and 3 4, right. So, we are getting same answer using Minitab output, right. So, this is how you can solve a question using Minitab on ANOVA having different sample sizes. Now, let us look at some assumptions about ANOVA. We did work out couple of examples using one way ANOVA. In other words, we have worked questions on completely randomized design, right. What is completely randomized design? Wherein there is only one independent variable having different treatment levels, right. So, before going for ANOVA, you need to fulfill certain assumptions. For example, the sample should be randomly selected from the different groups. We should ensure that the samples from where we are taking the populations are normal, and the most important assumption is homogeneity of variance. The variance of the populations from where we are selecting samples should be same. So, there should not be any difference amongst variances of different populations from where we are selecting samples. So, all the populations will have same variance, and it can be tested using a test called Levin's test. So, let us see what is Levin's test. So, in Levin's test, the first thing is we define our null and alternative hypothesis. So, null hypothesis is this. So, we will say that all these variances of the populations from where we are taking samples are same, right. So, all these variances are same. Alternative hypothesis is that they are not same, they are different from each other, or at least one of the variances is different from others. The second point here in Levin's test is we compute the absolute value of difference between each value and the median of each group. So, every group will have a median. So, that median value, from that median value we will subtract each of those values, and then we will perform one way ANOVA on these absolute differences. So, let us test one of the questions for equality of variances, right. So, let us look at this question. This, though we have already worked out this question, but what about variance? We have not checked equality of variance so far. So, null hypothesis, alternative hypothesis. So, what we have said in this Levin's test is that from each group we will select the median. So, from first group this is the median value, second group this is the median value, third group this is the median value, right. So, it is 251 minus 237, we will get 14, right. Then 251 minus 241 will get 10. So, we have to write absolute differences over here, right. 251 minus 251 0, right. 251 minus 263, this is good, right. This is actually 251 minus 263 is minus 12, but we have to write absolute value, right. So, this is 12. Similarly, 227 minus this, minus this, minus this, minus this, minus this, right. You will get all these values. Similarly, from group 3. So, this is the this table is about absolute differences, and what is the next step? We have to perform one way ANOVA on these absolute differences. So, when we perform this one way ANOVA on this, we should reject null hypothesis. No, we should not reject null hypothesis, isn't it? So, let us see whether we will rejecting null hypothesis or not on this value. So, we will perform one way hypothesis testing on this data, right. Let us look at this. So, we will go to we will have a new file. So, this is let us say club 1, club 2 and club 3, and for club 3 now we will enter the absolute differences, right. We will not write the actual values, right. So, this is for club 2 11, 9, 0, 7 and 8, for club 3 7, 4, 0, 2, 18. We will go to state, we will perform one way ANOVA, right. Okay, so we will select all these 3 values. We will go to options, in fact we should go to options, and of course we are testing it at 95% significance level. Let us check whether it is 95 or not. Yes, it is at 95% significance level. So, let us look at this. So, this lower bound will go to OK, then comparison. Okay, there is no need to click any other option. So, we will go to OK, click OK. So, let us look at ANOVA table. So, just minimize these two, right. So, let us look at ANOVA table. Now, if you look at the differences over here, we will go downward. Let's look at what is f value. Can we have some f value somewhere here? Just go upward, upside. Yeah, here it is, right. So, look at p value first. First, we will decide whether we are rejecting null hypothesis or null alternative hypothesis, right. So, this is p value. So, p value is just look at 0.91, 0.912 and alpha is 0.05. Is p value less than alpha? No. So, we will not reject null hypothesis. This is the p value, right. So, what conclusion we are drawing? We will not reject null hypothesis. What is our null hypothesis? Null hypothesis is that all these variances are same. So, we are not rejecting, it means we are saying that all these variances are same, and that is one of the conditions for performing ANOVA, right. So, this is how you can use Levin's test. In fact, before performing ANOVA you should perform Levin's test. So, if you let us say if you reject null hypothesis in Levin's test, you should not go for ANOVA. So, this is in fact a precondition for ANOVA. Okay. So, what we have done? We have performed one way ANOVA on absolute differences, but there is an option in Minitab wherein you can directly compare all the variances. So, let us look at the same question once again. This is the question we have got, this is the question. So, for simplicity let me remove all these points. So, we will take the same question and we will find out variances. We will directly compare their variances, not using this particular data. So, let us look at the Minitab solution to this question, right, and we will directly calculate whether the variances are same or not, right. So, we will go for data entry. Let us look at this. So, in fact, this can be maximized. Okay. So, club 1, club 2 and club 3. So, now we will write original values of the question, not the absolute differences. So, 263, then we have got 216, 218, 227, 234 and 235, 197, 200, 204, 206 and 222. Now, go to state and then go to ANOVA, right. In ANOVA there is an option over it, test for equal variances, right. So, you can directly go to there, that value, that point, test for equal variances. So, respondents data are in not in one column, but they are in separate columns, right. So, just select all these 3 values and we will go to options. So, use based on normal distribution, of course, you can click this. Okay. Let us look at what are other things. So, we will click at OK first, then graphs. Okay, there is no need of having other graphs. Let us look at storage. Let us look at click at variances, right. Okay, then OK. Let us look at the p value, right. We will go there, right. So, we are just test for equality of these 3 groups, right. So, significance level is this alpha, will go downwards. So, p value is this, p value is 0.951. So, p value is 9.951, which is more than alpha. So, we will not reject null hypothesis, is not it. Since p value is more than alpha, we will not reject null hypothesis, and when we say we are not rejecting null hypothesis, it means all these variances are same, all variances are equal, hence we proved the same thing. So, this is how you can in fact use either absolute differences for testing Levin's test, or you can directly enter original values in Minitab and compare variances. So, before moving on to the randomized block design, let me summarize what we have done in today's session. In today's session, we have looked at couple of examples on ANOVA. As all of you know that ANOVA is basically a tool for comparing means of 2 or more than 2 groups. Now, in ANOVA you have dependent variable and independent variable. So, in independent variable you have got different levels, which we call them treatment levels. So, if the number of sample sizes are same in different groups, then we should use something called Tukey HSD test, honestly significant difference test. We did work out couple of examples using Tukey HSD test. In today's class, we discussed about Tukey-Kramer test. Now, this is extension of Tukey HSD test. There is little change in the formula, otherwise everything is same as we have seen in HSD test. Now, apart from this, we have looked at couple of assumptions of ANOVA. So, the assumptions were, there were different assumptions. The first one was that the samples from where we are taking, let us say the populations from where we are taking samples should be normally distributed. The second assumption was that we should take samples in a random manner, random selection of the sample. The third assumption was Levin's test, and this assumption was for equality of variances or homogeneity of variances. So, this homogeneity of variances we have tested using Levin's test. Now, Levin's test can be done in two ways. The first is directly you can compare variances of different groups. There is an option in Minitab. So, you can directly enter your data, but keep in mind that in Levin's test you should always, you should not reject the null hypothesis, is not it? If you reject null hypothesis, you cannot do ANOVA. So, before performing ANOVA on any question, you should do Levin's test. The other way of testing equality of variance is, first you calculate the absolute differences from the given question and then enter those values in software and perform one way ANOVA. So, this is what we have done in today's session. In next session we will talk about randomized design, which is the second type of experiment design. Remember that I have told you that there are three types of experimental designs. The first one was completely randomized design, where there is only one independent variable and a dependent variable. In randomized block design, we will have a second variable as well, right. So, we will discuss about randomized block design in next session. Till then, goodbye. Thank you very much.